Problem number 21. A ball of mass 50 gram moving with a speed of 2 meter per second strikes a wall at an angle of incidence 45 degree and is reflected from the wall at the same angle and with the same speed. See the overhead view of the figure. In the first question, we are going to find the magnitude of the change in momentum of the ball. So for that, we have to take some information from the figure, especially related with x component and y component of the initial speed and the final speed. For change in momentum, we studied the rule mass multiplied by v final minus mass multiplied by v initial, right? So this is your final momentum pf, this is your initial momentum pi. So let's we find the initial momentum and the final momentum separate, and then finally we can find the answer. So let's we find the pi, that means the initial momentum. And initial momentum formula is nothing but mass multiplied by speed initial, that means the velocity vector vi vector. So if you see this diagram, the ball is coming with initial speed of 2 meter per second. So the ball, you can see the arrow mark. So if the arrow mark is towards in this direction and its angle of incidence, let's we take this theta is theta 1, this angle is theta 1 and this angle is theta 2, but both angles are exactly 45 degree and both speed, initial speed and the final speed are same, 2 meter per second. Now let's we consider only the incident, that means the initial speed of the ball, so with the incident angle of 45 degrees. So if you see the arrow mark, its x component will be in this direction, right? That means when you have the ball coming in this direction, its x component is moving towards in this direction. That means your x component is moving towards the negative direction of the x-axis. This is the positive direction. So your speed, the x component of the speed will be in the negative direction of the x. Likewise, your y component of the speed is moving towards the positive direction of the y. So this is your x component, this is your y component. So we can write this as mass multiplied by, where x component is moving to the negative direction. So we have to write minus vi multiplied by cosine of theta 1 I cap. And then we have to write its y component and it is moving to the positive direction. So plus vi of sine of theta 1 and its unit vector is k j cap. That's it. Clear? Now we have to find the same thing for the final momentum. You can see the arrow marks will be in this direction. So its x component will be in the positive direction of the x and your y component will be in the positive direction of the y. So the formula for the final momentum is nothing but mass multiplied by velocity final. That means the velocity of the ball final, which is equal to mass multiplied by, you can see based on this arrow, your x component is positive direction of the x. I'm talking about the final speed of the ball. Okay, so that means the final speed of x component which is moving in the positive direction of the x. So we have to write v final of cosine of theta 2 I cap, and then your v final y component is also moving to the positive direction of the y. So plus v final of sine theta 2 of j cap. Clear? So now we have to substitute this formula in delta p. So therefore delta p, which is equal to mass multiplied by v final minus v initial. Clear? Now I'm going to substitute this value in v final because the mass is a constant term. We can take it outside. So if you take it outside, what you'll get? Mass, which is 0.05, because 5 grams means 5 divided by 1000, we will get 0.05. Clear? 0.05. Sorry, it's not 5 grams, 50 grams. So 50 grams. So that means 0.05, right? And then we have to substitute the value here, v final. So how we can substitute? v final of cosine of theta 2 I cap minus of minus, because we have to consider only the velocity final. Clear? So velocity final with the initial. So x component separate, y component separate. So I am going to separate x component separate. Okay, so v initial minus of v initial cosine of theta 1 I cap. Clear? All these are I cap minus, let's we consider the y cap. So which is v final of sine of theta 2 j cap minus v initial of sine theta 1 j cap. Now we have to substitute the value here. Let's see what will be the answer. So mass 50 gram, which is nothing but 0.05 kilogram, and your V final is 2 multiplied by cosine of 45 degree, right? I cap minus into minus plus, so plus 2 Vi is also the same, so because minus into minus plus 2 is the initial speed, cosine of 45 degree I cap. Clear? Likewise, we have to do the same thing for j cap. 2 of sine of 45 degree j cap minus 2 of sine of 45 degree of j cap. So now you can see this becomes 4 cosine of 45 degree I cap. So 0.05 multiplied by 4 cosine of 45 degree, which is I cap. And then here 2 sine of 45 minus 2. So this becomes 0 minus 0. So now 0.05. Let's see what is inside the bracket. 4 multiplied by cosine of 45. I got the answer here as 2.828. 2.828. When I just multiply with 0.05 multiply with 2.828, I got the answer here as 0.141, or we can write 0.14, and its unit vector is I cap, and the unit for the momentum delta P, which is nothing but kilogram meter per second. This is the answer for the first part. Clear? Now we have to come for the second question. So what is given in the second question? We have to find its magnitude, right? The magnitude of the moment of the ball. So first we find the answer for the magnitude of the change in momentum of the ball. So second one, we are going to calculate the change in magnitude of the ball. So for the second part, what we have to do, we have to find the magnitude. So again, we have to substitute the value for Pi and Pf. By that, we will get the answer. So let's see Pi magnitude, because Pi we already wrote as minus V I cap cosine theta 1 I cap plus Vi of sine theta 1 j cap. I'm just writing the same equation multiplied by mass, and P final magnitude, which is nothing but V final cosine of theta 2 I cap plus V final of sine theta 2 j cap multiplied by mass. Clear? So don't consider this is the meter, this is the mass. Or I can do one thing better, I can write the value of the mass. So instead of mass, I can just multiply 0.05. Here also I can going to multiply by 0.05. Clear? This is mass. Now let's substitute the value and find the answer for the magnitude. So first of all, let's just find the answer for this. Mass multiplied by, so 0.05, substitute the value here. Minus 2 cosine of 45 is 0.707. So I can directly write the value, because cosine of 0.707 I cap, right? Plus 2 multiplied by 0.707 j cap. So if you take the magnitude, you will get 0.05 inside the bracket. You will get minus of 1.414 I cap plus 1.414 j cap. If you find the magnitude of x component and y component, what you will get? You will get the answer as 0.05 magnitude, which is nothing but square root of minus 1.414 square plus 1.414 square, right? Likewise, for the P final, you will get the same thing because only the sign is differ. So for P final, what you will get? 0.05. Here you will get 1.414 I cap plus 1.414 j cap you will get. So that means here also the same 0.05 square root of 1.414 square plus 1.414 square. So when you find the delta P magnitude, same answer, because you can see square root of, when you're squaring this, you will get the same answer. So what will be the answer? P final magnitude minus P initial magnitude, both will be same. So this number minus that number will be equal to 0. Clear? This for magnitude. Now we have to answer for the last question. Calculate the change in magnitude of the momentum of the wall. What is the momentum? Because the wall is stationary, it is not moving. If any object is moving, then only you will get the momentum. But the wall is at stationary, it is fixed. So the momentum, the delta P for the wall is 0. Why? Because the wall does not have any, it is not moving. So the momentum for the wall is 0. So the answer for the third question is simply, you have tried, delta P for the wall is 0. That's it. This is the answer for this question. Thank you.